Hi guys, we'll be talking about cis-1, 2 cyclohexane diol. Its molecular formula is C6H12O2. Its molecular weight is 116.16 grams per mole. Its degrees of unsaturation is 1. That's occupied by its ring right here. Its sigma bond is 20. We have to count the hydrogens on the oxygens right here. And we also have to count the hydrogens that are understood that are connected on these carbons right here too. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. There are no pi bonds. If there were pi bonds, the degrees of unsaturation will most likely be more than 1. The functional group present is called a diol because there are 2 hydroxyl groups that are connected to adjacent carbons. To be more specific, this is called a vicinal diol due to these hydroxyl groups being connected to adjacent carbons. If these hydroxyl groups were connected to the same carbon, it would be called a geminal diol, but just for simplicity reasons, it's a diol. Its melting point is at a range of 97 Celsius to 101 Celsius. Its boiling point is unknown, but digging a little deeper, it's 116 Celsius. Its physical state at 25 Celsius is solid. Its unique carbons is 3. This will be a unique carbon, this will be a unique carbon, and then this will be a unique carbon due to all 3 of them connecting to different carbons or heteroatoms. Excuse me. And then there's 4 unique hydrogen sets. 3 of them are occupied by the same unique carbons, but what makes it 4 is the hydrogens that are connected to the oxygen. That makes up the hydroxyl group and overall diol functional group. And the hydrogen set ratio of those 4 unique hydrogen sets is 2 by this carbon, 2 by this one, 1 by this one, and then 1 by the connected oxygen hydrogen bond. And the number of lone pairs is 4. This oxygen has 2 lone pairs, and then this oxygen has 2 lone pairs also, which make up a total of 4 lone pairs. And then for carbon hybridization, there's 6 sp3 because they're all sigma bonds, and there are none sp2 and none sp due to no double bonds or triple bonds being present. And the heteroatom in this molecule is the oxygen, these 2 oxygens right here. And then for classification for carbons, there are no CH3s due to every single carbon having at least 2 bonds to another atom other than hydrogen. But that makes way for CH2 to be possible in this compound. And that's a total of 4, which is 1, 2, 3, 4. And then CH being present, connecting to that oxygen. So that'll be 1, 2, and that's 2. And then there are no carbons that have no hydrogens. There are none of this. So I'm going to quickly make the ring of the molecule and explain to you what you're looking at. So this is the ring. It's illustrated as a chair conformation, and the reason it looks like that rather than your typical just ring is so others can better understand where the oxygens are at. So for example, this is called an equatorial bond, or that illustrated bond that's kind of at a slanted up angle. Well, this is called the axial bond, and it's more on a 90-degree angle from the general plane of the ring. And so it's illustrated like that so chemists can better understand the properties of the atoms that are connected to the carbons and figure out how they react to other molecules. So this is the diol group, these 2 carbons and 2 alcohols, and they're CH, and the rest of them, of the carbons, are CH2 that make up the rest of the ring. Thank you.